Integration. So like I said last week when we were doing antiderivatives, we were integrating. That's called integration. So we've done it already. Finding antiderivatives is probably the most common way to integrate. But why do we do it? What's purpose? What purpose? Like for example, when we did derivatives last semester, right? Derivatives were slope of tangent lines, right? It was the slope of the tangent line. That was its purpose. Integration has a different purpose. So what is integration? Integration is a process by which we find the area under a curve. So if you think of a graph, whatever the graph is, right? So from here, does whatever. What integration or what derivatives told us was at a single point, what is the slope of the tangent line, right? That was what derivatives told us. Integration tells us a different story. Integration says, what is the area created by that curve? What is the area? What is the length times width of those things? Well, finding area is not hard. You guys have been doing it since elementary school, finding area, right? But the thing about it is that most of our functions have curves, so it's hard. We can't really find, so it's hard to just go length times width, right? So we have different ways of doing that. One of them is finding the antiderivative. The antiderivative will help us find that area under the curve, okay? That's what integration is, area under the curve, right? Derivatives are slope of the tangent line last semester. This semester, integration is area under the curve, right? Area under, what is the area? How much is there under, okay? That's what integration is, okay? So one method is using antiderivatives. We did that last week. Today, we're going to do another method. Antiderivatives is probably the best method, but there is another method called rectangular or trapezoid approximation, right? Another word for it's Riemann sums. Riemann is the person who came up with this. It's an approximation. It's not the best, but one way is to do that. Okay, so what I want you to do first, it's blue on my paper, okay, but I know it's not on yours. Find the area under each of these guys. Find the area under each of these guys. That's what I want you to do right now. From 0 to 8, what is the area under the graph? It's blue, under the blue graph on mine. So the easiest way, which the way you guys probably did, was by creating rectangles or rectangles or squares, right? Because area of a rectangle is length times width, same with a square. That's probably the easiest way to do it, right? So you broke it up into little areas like this. The first is a square, 2 by 2, so that's 4. And then 2 by 3, which is 6. And then 2 by 1, which is 2. And then 2 by 5, which is 10. Add them all together, and you get 22. Right? Same thing with the other one, right? The only difference here, they're just smaller rectangles. 1 by rectangles, 1 by 5, 4 by 2, 1 by 3, 1, 2, 3, 4 by 4. So you get 13 plus 19 is 32, right?
It's a 3 by 2 and a
3 by 2, 3 by 2. Where's the 3 by? The last one is a 1, 2, 3, 4 by 4? No? Let's see. Oh, sorry. 1, 2, 3, 4. Okay, so it's 3 by 4, so that'd be 12. It's a 3 by 2. Let's see. 1, 2, 3 by 2. Yeah. So it'd be 11 plus 15, which is 26. Okay. So if the area, if the curve, that's not really a curve, right? So if the areas looks like, if the function, if f of x looks like either one of those, it's not too bad. So these are more what we would do, what we would see. So what I want you to do is use the method you just used above. Use the method you just used for the first two to try to approximate the area. I want you to approximate your area. Okay? Use the method you just used to try and approximate it. It's not going to be perfect. It's not going to be 100%, but you're going to get as close as you can. Okay, so using the method you just used, yours probably looks something like the one I just created. Maybe not exactly. Probably not exactly, right? But something about. We want area, we want to cover as much as the area under the curve as possible, right? There's missing. There's some parts missing, right? Here, let me use a different color. Right? There's some parts missing, like this little area here is missing, this little area here is missing, this little area here is missing. Same with here and here. And this part I probably shouldn't have counted, right? The orange is missing. I didn't count that. The yellow is area that I did count, but I shouldn't, right? So you find area of each of those 1 by 2, 1 by 2, 1 by 3, 1 by 3, 1 by 2, 1 by 2, 1 by 5, 1 by 5. You add them all together. What do you get? 10, 14, 24? Around 24, right? Same thing with the other one. You just do the best you can, right? You build rectangles as best you can. It's an approximation. So there's not going to be one method. There's not going to be one answer. Okay? So I get 2, 8, 4, 1, 2, 3, 12. So what is that? 10 plus 16, around 26 for that guy. Okay, you probably got something very, very similar, somewhere in the 20s, maybe a little bit above, maybe a little bit below, but that's an approximation. Okay, so that's one way. So this is one way to figure out area under the curve. It's called the approximation. It's called an approximation method. Okay, that's the first way we're going to do. That's the first way that we're going to approximate. Okay, so it's got a name. It's called, on the next page, it tells you all about it. It's called the rectangular approximation method, or RAM, also known as Riemann sums. Riemann is the person who discovered this. Okay? Suppose we wanted to know the area of the region bounded by the curve. So the gray stuff. Imagine if we wanted to find the area of the gray stuff. The same thing we've been discussing, right? It's a curve. Curves don't create shapes that we know besides circles, but none of those are circles. So it's kind of hard to be exact, right? So what Riemann said was we can create rectangles and then decide the area under the curve using rectangles. There's 3 types of rectangular approximation methods. The first one is called left rectangular approximation method. The other one, the second one is called right rectangular approximation method. And then the last one is called middle rectangular approximation method. LRAM, RRAM, MRAM. Okay? The width of the rectangles just depends on what we're looking at. Okay? So, for example number 1. The first one to the left. Look at the function. The function is in blue. I know it's not blue on yours, but it's blue on mine. Where does the blue touch the rectangles? Where is the blue always touching the rectangles? Corner, right? Which corner, more specifically? The top left, right? Top left corner of every single rectangle is touching. This is an example of LRAM, or left rectangular approximation method. Okay? When the corners, top left corners of the rectangle touch the function. Okay, look at the middle one, or the one on the right, the next to it. What part of the rectangle is touching the function? The middle, right? The middle, the midpoint of every single rectangle on top. That's an example of middle RAM or MRAM, rectangular approximation method. Okay? So the total area under the curve is approximately equal to the total area of all the rectangles. So I find the area of all the rectangles, add them all together. That's the method. Okay? It's not really a sophisticated method, but it is a method. Which of the graphs above would give a better approximation under the curve? How could it be further improved? Okay, so which one of these? So if I was to find, so I think the function's the same. The blue function is the same for both. Which one do you think would give a better idea of area under the curve, actual area under the curve? Which one would give a closer to the correct answer? The middle one looks like a little bit better, right? With the LRAM, left RAM, there's a lot missing here, right? This part, I need to find area of. I don't have it. This part, same thing here, and this part here, right? All of those areas are missing, and I need to find those areas. I go over a little bit. Oops, probably not the right color. I go over a little bit here, right? The other one does have some missing, but the missing's a little smaller, right? And I go over a little bit more. Right? But yeah, I would say MRAM is probably better. Here's my question. How could we get better? How could I do this same thing, still use LRAM, still use MRAM, but get better? So what I mean by better is less of the orange, less of the yellow. Or no, let me use a different color. Yellow, yeah. Yellow is the part that I don't want. How could I get better at coming close to the actual area under the curve? What would be a method I could use that would get a better answer? Something that's actually closer. Using another shape. Okay, so let's write this down. Maybe another shape besides a rectangle, right? That could work. What's another way? Changing the width, right? Making those red slices thinner slices, right? Changing width of rectangles, right? Thinner slices. Changing width of rectangles, thinner slices. I think both of those, I think you guys hit the nail on the head right there. Those two, if I could do those, I think that would give me a better idea. I'd be missing less, right? Imagine if I could cut up these red into thinner slices. I could fit more in there, right? That's essentially integration. Slicing them as thin as we can to fit all of those areas, right? Okay. All right, so now on the next page, we're actually going to do one. Actually, no. Yes, we are. So we'll do one together, and then the bottom is another example. Okay. Okay, so step one says they want us to use MRAM and LRAM on the function, the graphs below. So it's the same graph. So on one graph, we're going to use right RAM, RRAM. On the other one, we're going to use LRAM. Okay. Use 5 triangles. They want us to use 5 triangles. We can't use anything other than rectangles. Sorry, rectangles. We can't use anything other than rectangles, and we only can use 5 of them. Okay. So the first step: how wide should my rectangles be? How wide? Let's look at this one. If I can only use 5 rectangles, how do I decide how wide they should be? Does it say the rectangles have to be the same width? No. Doesn't say the rectangles have to be the same width. So I can have a wide rectangle, I can have a skinny rectangle, I can have, right? So it doesn't really matter. Sometimes they'll say the rectangles have to be equal width. Then we're stuck. Then there's no choice. But this one, they don't say that it has to be equal. They just say use 5. You can only use 5. Okay? So the first one, it has to be L. This one is RRAM. So whatever width the rectangle is, it has to touch the function on the right corner, top corner. Just like we saw, just like this is left RAM and MRAM, right? So right means the top right corner is going to touch the blue. The top right corner of each of the rectangles. Okay? So let's see. Okay, let's see. Mine, let's see. I probably have one. Let's see. So the right side's got to touch. So there's one there. There's one there. It's 2 rectangles. Let's see. 3 rectangles. 4. And then 5. The top right of every single rectangle is touching the blue. The top right is touching every single rectangle. 1, 2, 3, 4, 5 rectangles. The top right is always touching the blue. That's RN. Okay. So the next thing is find the area. 2 by 3 is 6. 2 by 3 is 6. 1 by 1 is 1. 1 by 5 is 5. 2 by 5 is 10. So 15, 16 plus 12 is 28. So around 28. On the next one, I'm going to do the same thing, but now the top left corner of each of the rectangles has to touch the blue. Okay. So let's see. The first rectangle has to start here. Maybe I'll go there. The top left has to touch. So 5 rectangles, all of them, the top left corner touches the blue. That's one example. Is that the only example? No, but that's one example that fits. The only requirement is that you have 5 rectangles and the top left corner touches the blue. If another corner touches the blue, great. But the top left corner of every single rectangle has to touch the blue. Okay? All right, so here we go. Let's see. This one's a 2 by 2. This one's a 2 by 3. This one's a 1 by 3. This is a 1 by 1. And this is a 2 by 5. 10, 24. So it's the same area, slightly different answers because it's a different approximation method. Okay. Okay, so now we're actually going to do an example here that is a little more of what you're going to see. Okay. So the function actually has its actual y equals x squared minus 2x plus 2. So that's the actual function. That's the actual graph there. It's a parabola. So what we're going to have to do is find area under the curve from 1 to 3. From 1 to 3. Okay, so let me section off 1 to 3. So 1 starts here, 3 ends here. For each of these. It's the same area, same graph, same area, but we're going to use 3 different methods. Okay. Same area, same region. Finding this area under the curve. We're going to find this yellow part, the area of that yellow part for all 3 of them. Okay, so it says we can only use 4 rectangles to approximate the area. Again, they don't say the rectangles have to be equal width, so that's up to us. But I'm going to show you how to do equal width because a lot of times they will mandate all the rectangles have to be the same width. Okay, so if we were going to do this with equal width, what would be the width of each of the rectangles? Not 1, half. It would actually be half, right? Half, it's from 1 to 3, so that's 2 units wide. Divide by 4, you get a half. Okay? So that's what we're going to do. Okay, so first thing we're going to do is draw. So the first one is an LRAM. Means the left side needs to touch. So we know that we're going to go only a half unit wide. We know we're going to go a half unit wide. Oops. Oops. So here, there. Okay. So the first one, so we start on the left side. So we're going to start on the left side. The left side is here. We're going to go up till we hit the blue, That's going to be the height of our first rectangle. So go up, touch the blue. That's the height right there. The next one, 1.5. Go up until you touch the blue. Blue, come over, come back down. 2, go up till you touch the blue. Come over, come back down. 2.5, go up till you touch the blue. Done. Those are going to be the rectangles for LRAM. Okay, we're going to actually find the area, but we'll do that later. I just want to draw the rectangles first. RRAM. So RRAM means the rectangles have to touch on the top right. So I'm not going to start on the left side. Before, with LRAM, I started on the left side of the first rectangle. Now I'm going to start on the right side of the first rectangle. So I'm actually going to start at 1.5. I'm going to start at 1.5 and go up until I touch the blue. So 1.5, go up until I touch the blue, stop. This time I'm going left and down. Go to 2. Go up, touch the blue, stop, go left, go down, make the rectangle. 2.5, same thing. Go up, touch the blue, come over, come down. Last one, 3, go up until you touch the blue, come over, come down. You just started in a different spot. On one, you start on the left side. On one, you start on the right side. Okay. The last one is MRAM. MRAM. So we're going to have the same 4 triangles, same width. So LRAM, we start on the left side. LRAM, I started at 1, went up, made the rectangle. RRAM, I started on the right side, went up, went left, made the rectangle. Where do you think I'm going to start for MRAM? The middle. So what is the middle of 1 to 1.5? Quarter, right? 1 1/4. So I'm going to start at 1 1/4, go up until I hit the blue, and then go both ways. So 1.5, you go up until you hit the blue. That's going to be your rectangle. Okay. Same thing. So now it's 1.75. Go up 1.75, make a dot. That's going to determine the height of my rectangle. 2.25. 2.75. And done. Okay. So that's how you draw the rectangles. All right. So now what we need to do, so now the table's on the next page, but what we need to do now is actually find the actual area of each of those rectangles. Do like what we did before. Find the area of the rectangle, add them all together. Well, luckily, area of a rectangle is not hard. Base times height, length times width. We know what width is. right? Isn't the width always going to be 0.5 for all of these guys? So we know what the width is. We just need to find the height. We just need to find the height. Okay. All right, so let's start with LRAM. So the first rectangle, the width is 0.5. The height, which side, for LRAM, which side determine the height? Left, right, or middle? Left. So we're only going to look at the left side for the height here. So I'm only looking at the left side and the width for the height. The right side did not determine the heights. Okay, so for LRAM, got 0.5, right? Times how high? 1, right? So 0.5 times 1. That's the first rectangle. The second rectangle, 0.5, right? 0.5, 0.5, whatever you want to write it. What's the height of the second rectangle? It looks like 1.25. Do you know that for a fact? No. Well, we're already approximating, right? This method is called approximation. So do we really want to approximate the approximation? No, then it would be way off, right? So what's a more concrete way of getting this height? What's a accurate way of getting that height? Rounding. I want to get this height here. So if I knew where this dot was, I know it's at 1.5 something, right? 1.5 something. How do I get this so I can get the height here? Not slope. Use the equation. Didn't they give us the equation? They said, here's the equation. There's a reason why they gave us an equation here, so that we can figure out the height. I think it's 1.25. I think it is. And you know what? You might be right. But like I said, this method is called approximation method. We're already approximating. So anytime we don't have to approximate, don't. Okay? Because you don't want to guess on a guess, because then it becomes way off. Okay? So let's use the equation. So how do we use the equation? So we want to figure out y. Which x value do I want to figure out y for? 1.5. Okay. So right here, I'm going to do a little bit of math. So I need to find f of 1.5. So it's 1.5 squared minus 2 times 1.5 plus 2. So 1.5 squared. 1.5 times 1.5. Well, 15 times 15 is 225. So you just move the decimal over twice, and you get 2.25. 2 times 1.5 is 3. So when we add and subtract, we get negative 0.75. So that would be positive 1.25. Our approximation was right. We didn't know that, but like I said, it was right. It looked like 1.25, and it turned out to be 1.25. So this height for the second is 1.25. Okay? So 0.5 times 1.25. Okay. Done. Done with those two rectangles. Now the third rectangle. The third rectangle goes 0.5 times how tall? 2. That's pretty definitive. Now, if you wanted to plug in 2 and do that, you could. But I'm not going to do that because that's pretty definitive at 2. Okay? So 0.5 times 2. One more. So that's the third rectangle. It looks like 2.5 is 3.25. It looks like it's 3.25 again. I'm going to check it just to be sure. Okay? So I'm going to go f of 2.5. 2.5 squared minus 2 times 2.5 plus 2. So I'm just using the same equation I used before. Instead, I'm plugging in 2.5. 25 times 25 is 625. So 2.5, you just move the decimal over. And instead of 625, it would be 6.25. 2 times 2.5 is 5 plus 2. 1.25 plus 2 is 3.25. So we were right. 3.25 high. Okay. All right. We'll do multiplication in a second here. But let's do RAM now. Let's do RAM. So this time, the side that determines the height is the right side, not the left side anymore. It's the right side. Okay? So here we go. We have a width of 0.5. How tall is that here? How do we know that? Without checking, how do we know that that's 1.25? Yeah, because we already checked it, right? We already checked the height at 1.5. We checked the height at 1.5, and we saw it was 1.25. So we don't need to do the math again. So the first rectangle for RAM is going to be 0.5 times 1.25. Next rectangle. Got a width of 0.5, height of, it looks like 2. So 0.5 times 2. Next one. Width of 0.5, height of, looks like 3.25. Do we know it's 3.25? Yeah, we do, because we did that on the last problem. We didn't know for 2.5, so we put in 2.5 and we got 3.25. So it's a width of half, height of 3.25. Now the last rectangle. Width of a half. How tall is this rectangle? 5, yeah. It's pretty definitive it's at 5. If you're not sure, plug in 3 to the equation and see if check if it's 5. But that one, pretty sure it's 5. It looks like it's 5. Okay, we'll calculate these in a second, but I just want to get the numbers. Last thing we'll do is we'll calculate them. Okay? Here we go now. MRAM. Now it's not the left side or the right side that determined the height. It was the midpoint, the middle. The midpoint that determined. So this guy here, it looks like it's just above 1, but I'm not sure if that's 1.1, 1.2, 1.25, 1.15. I'm not sure what that is. So I'm going to use the equation that I used earlier. And I haven't plugged in 1.5 yet. Or did I? I did plug in 1.5, right? But 1.25 is the one I actually need. 1.25 is the one I actually need. Okay, so I need to plug in 1.25. 1.25. So this one I'm going to use a calculator for because I'm not too sure about 2.25. I think it's 6, still 6 some, or no, 2 something. Okay, so here we go. 1.25 squared. 1.5625. 1.5625. Minus double 1 1/4, you get 2 1/2. Plus 2. Minus 2 1/4, or 2 1/2, plus 2. Get 1.0625. 1.0625. That's going to be the height, just above 1. First one done. Second one. The height was determined by 1.75. 1.75. We haven't done 1.75 yet, so we got to plug in 1.75. It looks like it's going to be 1 1/2. It looks like 1 1/2. Let's see. 1.75 squared minus 2 times 1.75 plus 2. It wasn't 1 1/2. It was approximately 1 1/2, but it was 1.5625. 1.5625. Okay, that's the second triangle. Third triangle. 2.25. 2.25. Okay. Okay. 2.25, I get 2.5625. 2.5625. Okay, last one. Is 2.75. 2.75 looks like 4 on the dot, but I don't know. That's it. So it's going to be 4, a little bit above 4, 4.0625. Okay, so the last thing I want you to do the calculations. Use a calculator. Do all of the calculations for each. This is the last thing we're going to do today. Okay, so we got a few minutes left. So I came up with 3.75 for the first one, 5.75 for the second one, and then 4.625 for the last one. Okay. We're going to do more practice on this process. That's what we'll do tomorrow. Okay. Tomorrow we'll just do more practice. Thursday I'll give you the practice on your own. Okay. So tomorrow we'll finish the notes.